Hello everyone, my name is Kimberly Del Torre and I'm going to take you through my Module 1 slides. A little about me, I am a 6th grade STEM teacher at East Middle School in Westminster, Maryland. I'm pursuing the STEM endorsement to just have a further understanding of STEM and improving the curriculum since it's not really well developed at my school yet. Some of the things I like doing when I'm not teaching is traveling. It's an expensive hobby, just being outdoors and kayaking when I can. So how do students learn science? I really just took this from chapter 9, where they talked about learning new concepts and theories with understanding, experiencing the process of inquiry that are key elements of the culture of science, and reflecting metacognitively on their own thinking and participation of scientific inquiry. So all of you already read that, but for my take on it was that students learn the new concepts through what their teacher is showing them, through different experiments and models. That's where they can see the different processes that explain some of the concepts, and then reflecting metacognitively, basically just trying to understand how they work and for the students to understand, ask themselves questions, maybe if they did an experiment or a project, really questioning why what they did makes sense. Some of the biggest barriers to science learning are the preconceptions, as we looked at in chapter 1. The prior knowledge can really lead to misinformation if their prior knowledge that they know is incorrect. So if they grew up always believing something, it could be something wrong. Or just not having the full information to guide them into the factual content. As stated in chapter 1, it can impose a serious constraint on understanding formal disciplines. So again, depending on how they understand the information, it will really change or kind of keep them from changing their mind on what they believe, just like we saw also in chapter 1 with the fish thinking, okay, well, I know this information, so if I just add these characteristics to a fish, this is my understanding of a human. How does your classroom adhere to the tenets of science learning described in the module readings? So in my classroom, because I teach STEM, I have a lot of different STEM challenges where they apply maybe concepts that they learned in science or concepts that they learned in math, and apply them to what they know in the real world. And a lot of times I just ask them, what do you know about bridges? What do you know about airplanes? What can you tell me that you already know about a parachute? So different preconceptions that they already have, and kind of using that as a baseline to how we move on with the rest of the unit. We also use the engineering design process with every challenge. So when they evaluate what they did and they work to improve, they're kind of doing that self-reflection and saying, okay, this is what I did. And they have to really explain to the rest of their group or explain to the class. When they present their solution, they're talking about what they did. So they're really using those skills to interpret what they're doing in their process. My STEM perspective, I tried looking at the different kind of disciplines that were shown in the chapter 8 by Bybee, where I think the integrated disciplines most reflected my teachings, just because I try to take the 4 content areas and see how I can work them together. But it also does change depending on the unit. I can't always work all 4 content areas into what we're doing, but typically we try to find the math aspect of it, find some science information about it, and see how they can build on it using the engineering design process. Here are my resources, and the favorite book that I have is Of the Places You'll Go. Thank you.